So for slide 11, we still have the same two functions as slide 10, but this time instead of proving graphically that they cross at the point 6, 7, we need to prove algebraically, which literally means using algebra. So we're going to have to do this by hand. I am working off of a Jamboard. Feel free to do this on paper, follow along, pause the video at any point to try it on your own. So I have these two functions, and what I need to do to prove that they cross algebraically is to set them equal to each other. So I'm going to have 2x minus 5 equals 1/3 x plus 5. And now this should look pretty familiar because we're going to solve this as a multi-step equation. So I'm actually going to copy and paste our steps for solving multi-step equations here. Give me a sec. Okay, so we have our steps for solving multi-step equations. Step number 1 is using the distributive property. Obviously, we don't have any parentheses, so our equation just stays the same. I like typing out all of my steps, but if this doesn't work for you and you just want to keep it the same, that is A-okay as well. Now I'm ready for step 2, which is combining like terms. Again, I'm looking if I have multiple variables on the left side or multiple constants on the left side, which I don't. I have one variable, one constant. Now I'm going to check on the right side. I've got one variable, one constant. So number 2 is going to stay the same. For step 3, I'm ready to use my boxes to simplify. So I need to look at my equation and see where my variable is bigger. So I have a 2x and I have 1/3 x. Obviously 2 is bigger than 1/3. So I'm going to keep my variables on the left side, which means my constants are going to come over to the right side. And then I'm going to adjust this a little bit just to keep the equal signs in the middle. Okay, so this 2x is just going to come down to be with my variables. And when the 1/3 x has to cross the equal sign, it becomes negative 1/3 x. Same thing with the constants. I'm going to bring the 5 down since it's already on the right side of the equation. And then this negative 5, when it comes over, becomes a positive 5. I am now ready to simplify using the boxes. So I have 2 minus 1/3. Pulling up my Desmos here. 2 minus 1/3. So that gives me 1, and this is 2/3. So I'm just going to put, here, 1 and 2/3 x. Now, 1 can also be written as 3/3. To make my life a little bit easier, I'm going to think about 1 as being 3/3. And then if I add 2/3 and 3/3 together, ultimately, I'm going to get 5/3x. Again, I'm just going to make my life a little bit easier by simplifying it like that. And then I'll simplify my constants, giving me a 10. And before we move on, I just want to do this part one more time. So if I have 2x minus 1/3 x, I'm left with 1 and 2/3 x. But this is really messy to deal with, and I don't really want to have to do that. So I'm going to change 1 to 3/3 because 3 divided by 3 is 1. I'm going to add 2/3 to it to ultimately get 5/3 x. Okay, so now I'm ready for step 4, which is bringing down what I have in my boxes. I'm actually going to write this. So I've got 5/3 x equals 10. I'm going to put the 10 over 1 so that I can do this problem by cross multiplying, which is going to make my life a lot easier. So I'm kind of running out of room here, but if I cross multiply, I'm going to get 30 equals 5x. And I'm just going to come over to this next screen. If you're working on your paper, keep working down. But at this point for number 4, I have that 30 equals 5x. And now I have to divide by the coefficient. So I have a 5 in front of my x. So I get that x is equal to 6, which is perfect because the problem is asking me to prove algebraically that the line crosses at 6, 7. 6 is my x value. So now if I put 6 in for both of these functions, I should get 7 as a result. So coming back to my paper, I've got these two functions, and I'll do this work over to the side. I'm going to start with f of x. And when I put in 6 for x, because that's what I need to do to make sure that my numbers work out, I should get 7 because, again, the problem's asking me to prove that these lines do cross at 6, 7. So 7 is my y value. I need to get 7 when I do this math. So that's going to leave me with f of x equals 12 minus 5, or that f of x is equal to 7, which is perfect. And I'm just going to double check this with g of x. So I'm going to put in a 6 here because that's what my x value is. I could even write this as g of 6, throwing in some function notation, plus 5. So I'm going to go back to Desmos. I have 1/3 times 6, which leaves me with a 2. And then I'm going to bring down this plus 5. Perfect. G of 6 is equal to 7. So both of my numbers, or both of my functions, when I put a 6 in for x, are equal to 7, which is exactly what I want. So what you need to do, since I did this on Jamboard, for example, I could take screenshots and upload them to this slides presentation, or you can upload images of your handwritten work, whichever you choose to do.